Hi, I'm Wolfgang Barth, and I'm presenting Nick Tipberger and my paper, the Codal Corpus Project. Here at Codal, we have an online collection of corpora of underrepresented languages, and we've been collecting corpora for the last 2 years. And it's pretty much my job to put them online, make the data available for other researchers. So why are we building corpora? The biggest reason is that little material is available for underrepresented languages, and it's easy to get big corpora of German or English, but it's really hard to get a big corpus for language in Vanuatu or Australia. We want to also give the communities and researchers access to the data that was collected by researchers. The researchers, we want to give the opportunity to go beyond example sentences for their hypothesis. And we also obviously want to develop new research questions based on access to the data. First, corpus is an exhibition of a language. It's also evidence of researchers' work. So a lot of people put a lot of work into collecting the data, and so it shows in the corpus. And if you have a nice corpus, it is something that you can really show around. And it's also a resource for language community and researchers. And at the end, it's a big untapped potential. So a lot of data has a lot of information in it, and why not make it available so that other people can do research on the data. For us, a corpus is not perfect. It never will be. So a corpus is always just an exhibition of part of a language and never the complete thing. And also the annotations are always what they are and not what people would want them to be. Okay, so any data is good. The more annotation, the better. But at the end, you can never have a complete picture of a language just by looking at a corpus. It's also, and I want to emphasize this, not a big task for the researcher. So putting a corpus together is not as much work as you might think. The challenges and solutions we faced in our project is that first, different researchers have different focus of their research. And so what we are trying to do is focus on a common feature in the language. That would be the individual words of the language and how they line up to form the corpus. There's also another challenge that different users have different expectation to what a corpus should look like. And we are trying to address that by offering different approaches to our collection. And maybe the biggest challenge is that the data of a language often comes in very different formats. So there might be old research being done and the files are available in toolbox format, and there's new research done and it's in ELAN files or in CLAN files. It might be an old a Bible translation, and all those things could potentially go into a corpus, but it's a little bit tricky to get them together, and that's what I'm going to talk about today. So here's a short overview of what that looks like. So in our collection, so far we have 41 corpora of 39 languages with over 8,000 files that we process to get into the corpus, and that makes together more than 5 million words if we count all the corpora. We have some small corpora with just a few thousand words in it, but we also have very large corpora. The biggest one right now is the blue line here in this graph is Bislama with over 2 million words in it. So there's a big variety between amount of words in the corpus, amount of annotation, how deep does the annotation go, is there a translation, is there gloss, is there a part of speech, and so on. And what that looks like on the website is what I'm gonna show you now. So here we are on the landing pages, and we get an overview of all the languages in our collection. There's a short description for each of the projects. Look at one in detail. We get an overview of the project, some photos, On the side, we get the information about the language, like alternative names, floater code, ISO code, the location, where the data is archived, and so on. We also get a map where the language is spoken. And down here, we get some example stories. And if I click on one, you can see the speaker, John Borg, and he's telling his life story. So, and if we go back to the Matukapanao overview, we also have a link here on the side, which brings us directly to the corpus in our corpus collection. So now we are the ANIS user interface, which is a visualizer for large corpora. Here on the side, we see the selection, the collection, all the corpora in there, and there's already Matukapanao selected, and we can immediately do a search for one of the terms, which in this case, we get 15 hits of Matukaranen. So what does our workflow look like? Usually we get the data in a USB drive, or we share a Dropbox folder with the researchers, or Cloud Store, or we just get an email from the researchers with the files attached. Whatever fits you works with us. In there, we usually find ELAN files, FlexText files, CSV files, Word documents, plain text documents, but also like CLAN files and pretty much any other format you can think of. And those are all then puzzle pieces for us, which we are trying to assemble into a cohesive corpus for our corpus viewer. So how do we put those pieces together? So if you look at data in an ELAN file, the ELAN user interface usually shows the data like this. So we have different tiers, and in the different tiers, there's different chunks of information which refer to the initial transcription of the audio. Under the hood, it looks a little bit different. So under the hood, an ELAN file is an XML structure with all the information and cross-references, so that the information in different fields fit together. So if we would have a transcription of an audio in an ELAN file, it would maybe look like this. And what we do technically is we just assign pretty much a position to every letter in the transcription. And then we have pretty much like house numbers for every word in the text. And any kind of annotation that refers to one of those words has then the same assigned house numbers. So the first annotation would start at letter 0 and would end at the letter 10. And the same thing is true for annotations which bridge over several words. They would just get the beginning letter and the number of the final letter attached at their location in the corpus. So what does this workflow actually look like when we're actually dealing with data? The first thing and the core thing is that we create a configuration file. And the configuration file is created automatically. It includes all the information about the file and all the internal structure of the file. And from this structure, we can then decide how the data of this file is depending on each other. The configuration file can then be manually edited to reflect all the changes that we want to happen to the data before we import it into the corpus. And the changed configuration file is then used to filter the data and to import it into the corpus the way we want it. But which part of the file actually goes into a corpus? So if you have, for example, an ELAN file, we might have transcription, we might have part of speech text, glosses, translations, notes, comments, and all kind of things in there. And some of those things you might want to have in your corpus, and other things you might not want to have in your corpus. And so once the configuration file is created automatically, you can then decide what to do with all those tiers and all the information. You can pick the main tiers from each of the files. You can select the annotations you want to include and the annotations you don't want to include. And you can change tier names. For example, if you want to anonymize your data, you can do that by just replacing the names with speaker one also. And you can also then add the metadata to the corpus, which then enriches the corpus to make it more searchable in the future. So once this is done, this manual step, we then take the whole bunch of the data again and run it through our script, and the script uses the configuration file to then process the data according to what we want. And at the end, we get the corpus. This corpus is then imported into ANIS, which is the corpus viewer, which I'm going to demonstrate in just a moment. And it can also be archived in Paradisic if the researcher wants to. So here we are again in the ANIS corpus viewer, and we already searched for Madhukaran. And let's just search for something else. Let's search for Gauni, and there we get 213 views in our corpus. We can filter those results. If we look at Gauni with a metadata tag 2013, and when we search, we get only 33 results this time. So the initial results get filtered by the date of the recording. We can also look for Gauni by participant. So we can look for Barry Guyao and how often we find Gauni in the recordings in which he speaks. And that is 15 cases. Another thing we can do is we can just get all the words out of the corpus and calculate the frequency. Perform frequency analysis. And then we get a distribution of the tokens across the corpus. Same we can do for bigrams. So if we search for token, followed by another token, and then draw a graph, perform frequency distribution, and then we get all the bigrams in the corpus and their frequency. Once we have result, we can also then export the data in different formats. CSV, the token by themselves, we can export a grid, or we can export a simple text file with all the search results in it. If we go back to the bigrams, we can also see that the structure of the ELAN file is now represented within the ANIS viewer. And we can search for a token with a special gloss or special part of speech tag with a special morphology and so on. And so the user interface, the ANIS user interface, is very versatile, and we can do like anything you would want to do with a corpus, you can do with our user interface. Yeah. And so that's pretty much it from me. So I want to thank all the communities and contributors, all the researchers and communities who contributed to our collection. And I particularly want to thank Daniel Barth for the examples of Madhukaran.